The first time I walked into Yoder's produce wash house outside Mount Hope, Holmes County, in the middle of August, I expected trapped heat. I expected the stale heat you feel under tin roofs. I expected wet concrete. I expected onions sweating in the dark. What I found instead changed something in me. The thermometer on my truck had read 91 degrees when I crossed County Road 77. Inside that building, my shoulders dropped before I even understood why. The air smelled like damp stone, cedar, and clean soil after rain. I heard wash water. I heard boots. I heard a screen door tap once in the frame. I did not hear a compressor. I did not hear a condenser fan. I did not hear the hard electric whine that now follows you through almost every American summer. I stood there for 14 minutes looking for the expected thing. It was not there. And that is when I understood I had been wrong about everything. I had accepted the same story you were taught. If you want a cool house, you buy a machine. If you want relief, you buy a bigger machine. If your rooms still feel hot, you buy insulation, then service, then another machine. Standing in that wash house, with cool air brushing my forearms, I understood something. The oldest cooling system in the world had never stopped working. It had only stopped being sold. I have been going back to Holmes County every summer for 3 years. And every time I find something the building industry forgot on purpose. Here is the promise. You can pull 68-degree air into your house on a 95-degree day without conventional air conditioning. If you follow the measurements, you can do it for less than $472 in materials. And yes, this works even if your house was built 50 years ago, you live in a city, you have never done this before, and you do not have land beyond a small yard. Stay with me. Because what I found in Holmes County uses the same physics the Persians used to cool desert structures more than 2,000 years ago. I am not promising fantasy. I am promising relief you can measure with your own thermometer. You will understand where the cool comes from. You will understand why the room changes. And you will understand why old farmhouses kept working after the power bill became the center of modern comfort. Once you see the temperature shift happen with soil, shade, and airflow, you stop asking whether it is possible. You start asking why this was hidden in plain sight. The science is almost embarrassingly simple. Below the frost line, the Earth does not chase the weather the way your attic does. It barely moves. In a 2021 Earth-to-Air Thermal Exchanger Guide, Natural Resources Canada explains something crucial. Soil temperatures deeper than 2 meters stay fairly constant. They track the annual mean air temperature. They do not chase the afternoon heat spike trying to cook your roof. That matters, because your house does not need magic. It needs contact with a stable temperature reservoir. Think about your own body. When you wrap a wet bandana around your neck, you are not creating cold. You are moving heat out of the place that feels overwhelmed and into a place that can absorb it. The ground does the same thing, only better, because it has mass. A lot of it. Natural Resources Canada also cited measured cases in Bemidji, Minnesota. There, an earth tube system met an entire summer cooling load. The same principle also preheated winter air from -29 degrees Celsius to -4. That is not theory. That is measured performance. Once you bury a smooth pipe 6 to 8 feet down and move outdoor air through it, the heat starts leaving the air. It moves into cooler soil. In the same 2021 guide, a modeled tube delivered up to 3.66 kilowatts of cooling in the first 30 meters. Engineers call the ratio between useful cooling and the energy you spend moving air a coefficient of performance. In practice, a small earth tube with a 40 to 90 watt inline fan can give you around 18 to 32 units of cooling for every 1 unit of electrical input. A typical room air conditioner gives you roughly 2.8 to 3.4. That gap is enormous. That gap represents a massive market in equipment, refrigerant, contracts, and service every year. And that is why you have never heard of this. There is another reason this works so well in a real house. Your house does not only gain heat through air, it gains heat through surfaces. Roof decking bakes. Attic insulation warms up. Drywall stores that warmth and gives it back to you after sunset. The Department of Energy has spent years explaining the same lesson in geothermal guidance. The ground is a heat sink with a far steadier profile than outdoor air. When you feed your rooms air that already came closer to ground temperature, you lower the starting point for every other cooling move you make. Ceiling fans feel stronger. Night flushing works faster. Shading pays back harder. It stacks, and that stack is the secret. You are not asking one buried pipe to do the whole job alone. You are asking it to move the baseline. That is why the best old houses feel different even before you know why. The cool arrives in layers. First the incoming air changes. Then the surfaces stop climbing. Then your body stops fighting the room. The result feels bigger than the parts. I saw the living proof in Berlin, Ohio, not in a lab. It was late July. The gravel drive popped in the sun. The porch boards were hot enough to sting through thin soles. But the kitchen I walked into felt calm. Not refrigerated, not damp, calm. I remember hearing a clock, a fly screen tapping, and one pan shifting on a wood stove that was cold for the season. I remember the total absence of machinery. No humming condenser, no duct roar, no supply register hiss, just still air that felt already settled. Eli told me the old people on his side had been using some version of this for 4 generations. He did not say it like a boast. He said it the way you would say the sun comes up in the east. He pointed toward the bank behind the house and told me the cool starts there, then moves where you need it. He told me his people brought the habit from families in the Palatinate and Canton Burn. They learned cellar building there. Then they carried it through Pennsylvania and into Ohio. Nobody told you. Not your builder, not your contractor, not the man who sold you another compressor. When I got home, I went looking for paper. I found it. Uzda Farmer's Bulletin 879 from 1917 described the same root cellar logic in plain language. Cool air enters low, warmer air leaves high. The earth holds the temperature line better than the weather ever will. That knowledge never disappeared. It was filed away. It was waiting. I found the same pattern in conversation. Lydia, standing by a cellar door near Strasbourg, told me she could tell a bad summer week by the smell before she felt it. If the lower door stayed dry and the upper vent breathed, the kitchen stayed gentle. If somebody forgot the vent, the warmth sat down in the room and refused to leave. She was not quoting a manual. She was quoting repetition. That is how old knowledge survives. It survives in ordinary sentences that never needed prestige to stay true. Go back far enough and you stop calling this alternative. You start calling it human memory. In Yazd, Persian builders used wind catchers tied to underground water channels. Air entered high, dropped through the tower, touched cooler masonry and water, and fell into living spaces as much as 12 degrees Celsius cooler than the air outside. In Roman North Africa and the Eastern Mediterranean, thick masonry, shaded courts, and subterranean cistern rooms kept interior spaces livable when stone streets radiated brutal afternoon heat. In medieval German regions, including Württemberg and Bavaria, food cellars were cut below grade because the soil held steady when the weather would not. These people were not sharing blueprints. They were sharing a planet. The Persians did not read this in a textbook. They figured it out the way all real knowledge gets discovered, by paying attention to what the earth was already doing. Every civilization that mastered extreme heat arrived at the same answer independently. The Amish never forgot. They carried it from Canton Burn and the Palatinate to Pennsylvania and Ohio roughly 300 years ago. They kept building it because it worked. They never needed anyone's permission to do what made sense. And once you understand that chain, the modern house starts to look strange. We live in boxes that trap solar gain, cook the attic, and then ask a compressor to rescue us from our own design. That is backwards. The old answer came first. The purchased answer came later. Not because it worked better, because it invoiced better. Now comes the part that should make you angry. In 1921, Willis Carrier secured the centrifugal refrigeration patent that turned large-scale mechanical cooling into a serious commercial empire. By 1930, Carrier Engineering had joined with Brunswick, Crochelle, and York interests to form Carrier Corporation. A single prestige installation could mean hundreds of thousands of dollars in chillers, coils, ducts, controls, and us from our own design. That is backwards. The old answer came first. The purchased answer came later. Not because it worked better, because it invoiced better. Now comes the part that should make you angry. In 1921, Willis Carrier secured the centrifugal refrigeration patent that turned large-scale mechanical cooling into a serious commercial empire. By 1930, Carrier Engineering had joined with Brunswick, Crochelle, and York interests to form Carrier Corporation. A single prestige installation could mean hundreds of thousands of dollars in chillers, coils, ducts, controls, and service in Depression-era money. A house cooled by dirt, shade, and moving air threatened every dollar of repeat equipment that system promised. The suppression did not happen with one dramatic ban. It happened with language. It happened with prestige. It happened because purchased comfort became more profitable than design comfort. In the July 1929 issue of Heating, Piping, and Air Conditioning, the Milam building was celebrated as the first office building completely equipped for air conditioning to provide year-round comfort. 2 decades later, ASHRAE and then ASHRAE design culture normalized the sealed, mechanically conditioned building as the professional ideal. Once comfort became something sold by machinery, architecture schools taught equipment sizing instead of climate response. Code culture followed the same prestige trail. The Allies were real. Carrier sold the hardware. General Electric and the electrical industry sold the all-electric future around it. In 1956, the Live Better Electrically campaign put Ronald Reagan in front of the public as a paid spokesman for the electric home. By then, his face was already familiar in American media. Government helped build the delivery system. The Rural Electrification Administration financed the wires. Utilities needed summer load. Manufacturers needed houses that bought machines instead of solving heat with form, shade, and earth. The money flowed in one direction. An entire field of knowledge disappeared from architecture schools, building habits, and ordinary memory. Not because it failed, because it was not profitable. And the modern continuation is not subtle. In December 2019, more than 1,000 government representatives voted to improve the 2021 International Energy Conservation Code by roughly 10%. Then the appeals came. The National Association of Home Builders fought the changes. In March 2021, the International Code Council Board removed the final government member vote from the process. The fight was framed as affordability. The financial motive was simpler. Better envelopes, better shading, and lower loads mean smaller equipment, fewer replacements, and less energy sold over time. The U.S. HVAC market is worth more than $33.81 billion a year. Every passive alternative installed is a unit of cooling equipment that never gets sold, serviced, financed, or replaced. And you can watch the language repeat itself even now. Better comfort gets called unrealistic. Lower loads get called fringe. Designs that need less equipment get treated like a threat to labor, when the real threat is to the invoice chain that starts with the sale and ends with the replacement. Not because it failed, because someone needed the monthly bill to remain normal. Now, if you already own a house and you're thinking this only applies to people with land, stay with me, because this next part is specifically for you. You don't need to tear up your foundation, rip out your existing system, or buy equipment. You need a yard, a drill, and a weekend. Here is the blueprint I wish someone had handed you 10 years ago. You start on the shaded side of the house, preferably the north or east side. There, the intake avoids the worst afternoon heat. You mark a trench 48 to 72 feet long. Shorter than 40 feet is not enough exchange. Longer than 80 feet adds digging without much extra benefit in most yards. You dig so the top of the pipe sits 6.5 to 8 feet below grade. The temperature swing calms down hard at that depth. Keep the trench about 12 to 16 inches wide, so backfill stays manageable and compacts well. Use 4-inch or 6-inch smooth wall HDPE or SDR35 pipe, not corrugated drain line. Slope that pipe 2% back toward a condensate drain point. That means about 1/4 inch of fall per foot. Wrap the run in non-woven geotextile where your soil stays wet. Bed it in 3 to 4 inches of washed gravel. Finish the intake with stainless steel insect mesh. At the house end, bring the pipe into a basement rim bay, crawl space plenum, or a low wall sleeve. Then attach an EC inline duct fan in the 40 to 90 watt range. Add a clean-out tee at the low end. Add a condensate trap. Add a backdraft damper. The measurements matter. The smooth wall matters. The slope matters. Corrugated pipe is not optional. Cheap perforated drain tile causes standing water. It causes biofilm. It creates the exact mold problem critics love to use against this method. If your soil is heavy clay, keep 6 inches of gravel below and around the pipe. If your lot is sandy and dry, 3 inches is enough. If the run crosses full sun, lay 1-inch rigid mineral wool board or foam above the top 18 inches of backfill for the first 20 feet. That reduces surface heat bleed in July. Material cost stays lower than you think if you do the labor yourself. The pipe usually runs $160 to $240. The inline fan runs $89 to $146. Mesh, fittings, a condensate tee, and a backdraft damper add $41 to $78. Gravel and geotextile usually land between $36 and $84. Even if you rent a walk-behind trencher for $92 to $148 for one Saturday morning, your total typically stays between $418 and $496. If you already own a trenching attachment or you are tying into an open landscaping job, it drops fast. If your lot is tight, shorten the run and improve the intake instead of giving up. A 42-foot run at 7.5 feet deep still beats hot outdoor air by a wide margin if the intake stays shaded and screened. If you cannot bring the pipe directly into living space, terminate it in a basement or crawl space and use a transfer fan to move the cool where you want it. If you already own window units, keep them. Use them less. Let the earth tube handle the hours when you usually need a machine just to take the edge off. That is where the savings start. What do you get back? On a 95-degree day, with shaded intake air and a 60-foot buried run, you can expect supply air in the 68 to 74-degree range. That happens before it even reaches a room fan or a night flush routine. In dry climates, it feels stronger because the incoming air is cooler than your interior surfaces. In humid climates, it still cuts sensible load and gives you air movement where the house would otherwise feel dead. Pair it with window shading and attic venting and the difference is immediate. 40 minutes after startup is usually enough to feel it. Maintenance is simple. You inspect the screen once a month in summer. You flush the condensate trap once a season. You open the clean out and look for debris once a year. That is it. A conventional central air system costs $6,400 to $12,800 to install. In hot states, it costs $96 to $214 per month to run. It lasts 12 to 15 years before part of it ends up in a landfill. This costs $418 to $496 total. It lasts 25 to 35 years. Your choice. Everything I have covered across this channel: root cellar airflow, lime wash walls, rainwater storage, I have put it all in one place. Step by step, season by season, room by room, in the order families actually use it. Link is in the description, but stay here, because what Eli built into that hillside is the part nobody is talking about yet. What changed me was not the temperature, it was the insult. Once you see a buried pipe, a shaded intake, and a little fan move that much heat for that little money, you cannot unsee the lie. You cannot go back to believing comfort begins at the thermostat and ends at the service invoice. Nobody told you. Not your builder, not your contractor, not the man who sold you another compressor. They sold you dependence first. Then they sold you relief from the dependence. That is why this subject never stays small for me. I cannot look at a summer power bill the same way anymore. I cannot hear a condenser start without thinking about how much of that burden began as a design choice. I cannot walk into one more old farmhouse and feel that settled air without asking how many useful things were dismissed simply because they were hard to patent and easy to copy. And this is where you and I stop pretending this is just about cooling. It is about memory. It is about whether knowledge belongs to families who use it or industries that meter it. When you bury a line, set the slope, screen the intake, and feel that first wave of 70-degree air come into a hot room, you are not trying something trendy. You are rejoining a chain of attention that never broke in the places still humble enough to trust what works. If you are the kind of person who believes that real knowledge has been quietly pushed aside to protect someone else's profit, you already know what to do. Hit subscribe. Not for me, for what comes next. Because this is not a channel, this is a quiet movement of people who have decided they are done being sold what they already own. I want to hear from you. Drop your state, your usual July electric bill, and whether your grandparents ever used a cellar, a whole house fan, or a shaded porch trick in the comments. I read every single one, and your answers decide what we cover next. Maybe nobody around you has ever shown you this. Maybe your neighborhood covenant would laugh. Maybe your contractor would wave it off before hearing the measurements. Do it anyway. Start small. Dig the test run. Log the intake temperature at noon. Log the outlet temperature 40 minutes later. Write the numbers on cardboard with a marker if you have to. Then look at them. That moment matters, because you are no longer arguing with an industry. You are reading your own ground. You are learning your own house. You are watching heat move with your own hands. That kind of proof changes a person. It makes you calmer. It makes you harder to sell to, and it reminds you that self-reliance is not nostalgia. It is applied observation. The people who kept this alive did not win by talking louder. They won by staying comfortable while everyone else kept paying. You can do the same. Quietly, precisely, season after season. One measured result. One cooler room. One smaller bill. One less lie. That is how buried knowledge returns. Not in headlines, in notebooks, thermometers, shovel cuts, and the shock on your face. If you try this, tell me your pipe length, your soil type, and your afternoon outdoor temperature when you test it. Tell me whether the first change you felt was on your skin, on the walls, or in the electric bill. Tell me what your grandfather called the coolest room in the house. Those details matter. Real knowledge grows that way. One measured result at a time. Next week I am going to show you what a 1946 Penn State document reveals about keeping a pantry cold with nothing but airflow, lime, and water. And the bulletin that proves agricultural extension offices knew this decades before the modern kitchen buried it. You are not going to want to miss that one.